Hi everyone, my name is Hannah Guarezi. I'm a PhD student at RMIT in Australia, and today I'll present a paper called Evoking Empathy with Visually Impaired People Through an Augmented Reality Embodiment Experience. So back in 1989, an exhibition named Dialogue in the Dark began to run internationally as a visual impairment awareness experience. There, visitors would face absolute darkness while performing daily activities such as walking in a park or visiting a coffee shop in specially designed darker rooms. More recently, researchers have claimed that the responsibility of addressing disability should be placed on everyone collectively, including technology designers, while others have claimed VR to be the ultimate empathy machine, although perhaps that might be a little too bold of a statement in some fields, especially psychology. In that line of thought, by working together with a visually impaired researcher during its conception and development, and combining concepts from other related projects, this work introduces an AR experience that focuses on providing players a sense of empathy with people who are blind or visually impaired. Along with the experience, we performed user experiments to try and measure any actual effects this sort of experience might produce on people's state or situational empathy. By exploring related works in the literature, we gathered that immersive virtual environments are able to supply users with sensorial cues that can empower experiences with lifelike features. In order to guide user perception into experiencing situations from another person's perspective, self-representation in VR has been explored and manipulated by some projects, usually in an effort to embody diverse conditions and traits, like a different gender, nationality, physical stature, mental illness, and even disabilities. However, none of these have had any metrics applied for emotional response. Contrary to most, two other studies have used the same emotional response scales we did to measure change in people's empathic response. However, both were limited to address VR as a 360 video displayed in a VR headset, so the actual immersion and interaction in those cases are arguably low. Focusing on blindness simulation experiences, both commercial and academic works have been implemented recently in VR, such as immersive documentaries, games, and VR experiences. In contrast to these works, our application focuses on providing the player with an augmented reality approach, being set in an actual kitchen environment, allowing users to move around and touch the real furniture and objects, empowering them with spatial audio micro-guidance cues, and speech recognition for interaction, having a very similar experience to what we expect a totally blind person would have in using sonified AR as assistive tech. As to validate this research in first place, a survey was provided to the BVI community with questions regarding their opinions on the need of empathy-evoking experiences and whether they believed these experiences to be beneficial. When asked if they felt there was a need for sighted people to better understand what they go through on their day-to-day, 80% of them agreed to it at some degree. 70% also believed that by having sighted people interact with assistive technology, the sighted could also improve their empathy responses, while 60% agreed that by improving their empathy, new assistive technology will emerge. Based on this feedback, we believe this work explores a valuable gap that is in line with the BVI community's belief and has a potential outcome not solely on increasing empathy across society, but also on the development of novel assistive technologies. Regarding the experiment scenario, we had blindfolded participants perform close-range navigation and object handling tasks in a real kitchen environment while listening to audio guidance methods calibrated and displayed by HoloLens 2. Participants will listen to audio instructions on how the experiment and the guidance worked and interact with it via voice commands. People went through 30 trials of trying to place a small plastic token into different paper plates spread around a large cupboard, being solely guided by spatialized audio feedback and their own sense of touch. The audio guidance used as assistive AR in this experiment was adapted from different state-of-the-art guidance sonification systems from the literature. The implemented guidance used spatialized audio beacons coming from the current target based on the user's hand position. Dynamic tempo was used to convey the horizontal distance to the target, with faster tempo meaning closer distance, and vice versa. For the vertical guidance, we used a fixed pitch to indicate each of the 5 shelf heights the targets could be at. All were based on musical notes at different octaves, with the lowest one, which was B3, around 250 Hz, indicating the floor level, and the highest pitch, which was D6, around 1200 Hz, indicating the top shelf. So in order to effectively measure emotional response from the users, we adapted the Ad Response Sympathy and Empathy scales, namely ARS and ARE. Originally meant to measure the public response while watching advertising pieces in the form of video, we adapted the phrasing of all its statements into 3 different versions. One in the form of a survey for the BVI community, as to assess their view on sighted people's emotional responses towards them. A second one as a pretest for the sighted people who applied to participate, assessing their self-reported emotional response towards visually impaired people based on their overall life experiences. And finally, a third one as a post-test to be applied after the experiment was done, to assess what was their self-reported emotional response towards that community during the experiment, that is, while embodying a similar condition, relying on assistive technology, and performing a generic day-to-day task. So here we are disclosing the adaptations both for the sympathy and for the empathy statements. Once the experiment was set up, we invited a visually impaired expert in digital accessibility to perform the trials and suggest any changes to the protocol or the experience itself. Based on their feedback, we made several changes to the hypothesis, phrasing of the questions, and the future of our research as a whole. Here's a small video demonstration of what the users went through in the trials. Regarding the volunteers, we had in total 97 people participating in the survey, out of which 20 had low vision or were totally blind. In the in-person experiment, 16 people volunteered to participate, out of which 1 had low vision. So now in the comparison between BVI people's perceived to sighted people's self-reported emotional responses regarding their previous life experiences with the other demographic, an increase of a bit over 16% on the sympathy scale, the left columns here, and of 12% on the empathy scale were noticed, both being statistically significant results. This implies that people with visual impairments generally perceive sighted people to sympathize and empathize with their BVI condition significantly less than sighted people self-reported to do. Now, when comparing sighted people's self-reported pre-test to their self-reported post-test results, an increase of 16% on sympathy and 23% on empathy was noticed. This suggests that sighted people in general will feel significantly more sympathetic and empathetic to the BVI condition after participating in the experiment than they previously were. Considering the results and the methodology used, we can arguably arrive to some conclusions and even limitations of the work. First, regarding the first comparison, it may very well be that sighted people believe themselves to be more empathetic than what they truly are. If that's the case, we may be due to social desirability bias, which is a tendency to choose responses that are more socially acceptable. Although those that did not participate in the in-person experience were completely anonymous, this bias can be unconscious, meaning that the participant would be unaware that they were responding in a biased way. The disparity could also be due to sighted people not conveying this self-reported empathy strongly enough towards the BVI community, or that their experiences do not involve in-person or direct communication with BVI people. As to the pre-test and post-test comparison, the results supported the idea that AR experiences can affect people's emotional response towards different lived experiences, particularly in our case, those with visual impairments. By using a proposed assistive technology in a real environment similar to what a BVI person may in the future have in their home, workplace, or public buildings, instead of a purely simulational VR experience, we hope to have demonstrated a good balance between people's struggles and the ability to pursue independence through technology. Finally, we believe the sonified AR experience pushed the current boundaries in AR by creating an empathy-provoking experience for the embodiment of difference, while also shedding light on including people who are visually impaired in the AR paradigm via an accessible interface. As for the future, we will be using the performance data collected during these trials into a study on the usability of different sonified assistive technology methods for microguidance. By observing the use of these by the visually impaired community, we intend on optimizing them to the community needs, coming up with new methods that may pave the way for accessible applications in AR, which is expected by some to take over user interfaces in the near future. So that was all I had for today. Thanks for listening, and I'll be here for any questions.